हाँ सर, आप लाइव हैं सर।
Good morning and welcome for this session. This is the very first live interaction session for this course. We will have two more sessions, so let the questions come. Any questions that you have, please let them come. I'll be very happy to give answers. I think people will still join slowly. If you have any questions, you can put them in the chat. I will give answers to all the questions as far as possible. Of course, if you ask me what questions are going to come in the final exam, that is something that I won't be able to answer. But in general, I'll be able to answer almost everything. There was a form which was circulated together with the notice for this live interaction session, and some questions are asked in that form. So I will discuss those questions also. But I will let people join so that we have a sizable audience. Otherwise, I tend to have to repeat everything again and again. So it is better that people join and then we start answering. I hope everyone is doing well. The monsoon has come with full power this year. One important component of this course is the assignment. And I hope that many of you are trying these assignment questions. These are not very difficult questions. They are, of course, you have to do some computations and understand the theory well, and then have to do the computations. There is one suggestion which is given, which is that in the assignments, ask only one correct option. This is a good question, and it allows me to discuss something very important part. So let me spend some time on that. What happens is that whenever a question is asked in the assignment, there are some 4, 5, or 6 options that are given. And of course, there are two ways to solve the assignment problems. What one can do is that you should solve the problem and then see which options are correct, or you should just take the options one by one and try to see whether the answer, the option is giving you the correct answer. If there is only one correct option, and suppose that correct option turns out to be the third option, then after the third option, you will not check the other options, which is something I don't want my students to do. My students should check all possible answers, and that is why I have kept more than one correct options. So I want my students to know not just that there is one or two correct answers, but also that all other answers are not correct. So my students should get the full information from the question. This is what I want my students to have, and therefore the answers can be many correct answers, and that is why we have given questions which have answers which are more than one correct answer. So this was a question asked by somebody in the form saying kindly ask only the single correct option questions. And good morning, Mayank. It's very good to have you here. I am really happy that you are liking this course. I hope this continues. There are some interesting things yet to come in the course. The last part, especially, is going to be very interesting. I will go to another question which is asked in the form. So I hope that you have been given the answers to all the assignments so far, at least to the assignment 3. Good morning, everyone who had joined. Vishal Kumar, Captain Shaw, Lokanath Panda, Isha Pandey, Uma Nag. Okay, so Uma Nag has a question in the solution of assignment 3. I have a doubt on one question. So please ask me which question you have a doubt on and I will try to answer that. Good morning, Raju Babu. So assignment 3, question 1, Punitha Lakshmi had asked in the Google form. In question 1, how is the option D true? OP Legend, good morning. So if you remember assignment 3, question 1, it said choose all the correct options from those given below, and option D was there is a polynomial with rational coefficients that takes all rational values. So, meaning when a polynomial is supposed to take values, it doesn't mean that it takes only those values. That's not what we are saying. It can take other values also. And therefore, the very simple example of fx equal to x will work. Because fx equal to x is a polynomial, you could take fx equal to 3x, fx equal to 5 upon 27x, any of these will work. So there are polynomials which take only uh, of course, if you were asking whether there are polynomials which would take only rational values, that is a different question. But what we are saying here is that there is a polynomial with rational coefficients which takes all rational values. And here is a polynomial, fx equal to x. This is a polynomial. In fact, this fx equal to x works for all 4 options. So all 4 options are correct and the polynomial is fx equal to x. Venkata Narasimha Murthy, good morning. Umaji, please ask your question. You said that in the solution of assignment 3, you had a doubt on one question. Please ask. In the same assignment question, there were problems 6 and 7. So problem 6, so this is assignment 3, problem 6, which said that if 5 power k is congruent to 5 mod 10, then, and then there were 5 options. The first one was that k can be any natural number. Second was k can be any natural number with k congruent to 1 mod 5. Then 2 mod 5, 3 mod 5, 4 mod 5, and so on. Question 7. Okay, I'll come to that also. So there is a difference between the answers given to assignment question 6 and question 7. When we say that k can be any natural number, it means that it allows you to have other possibilities also. So k can be any natural number with k congruent to 1. That allows you to have the possibility that k can be natural number with k congruent to 2 mod 5. So B and C, although these are mutually exclusive options, they are allowed in the sentencing itself. Whereas when we look at problem 7, then problem 7 says that if A in Z27 is a solution to 6x equal to 3, then A equal to 5. When you say A equal to 5, it means that that is the only answer. There is no other answer which is possible because you are saying that it is equal to 5. Good morning, Mari. So therefore, A equal to 5, A equal to 14 and A equal to 23, these are definite answer. You are not saying that can be 5. You are saying that A is equal to 5. No other possibility is allowed. When we write mathematics, although there are some symbols that is used, those are also some sentences. One should think of these as sentences. So when you say a equal to 5, the meaning of that is a is equal to 5. A is 5. And then when you say a is 5, then a is 14 is not allowed. If you are putting this as a can be 5 or a can be 14 or a can be 23, then that's a different thing. What we are doing in question 6 is that we are allowing for other possibilities. And in question 7, there are other possibilities are not there. And therefore, in question 7, E is the only answer which is correct, which is that A is in the set 5, 14, 23. Okay, so that is why the options A, B, C are not correct. Only the option E is correct. Mayank is asking whether so that he wants to study theory of cryptography. Can you please shed some light on how it is used here? So, Mayank, you mean how number theory is used in cryptography, right? Not for cryptography being used in number theory. So, we will see. We will discuss how number theory is used in cryptography. Mari MPhil is saying, please explain modulus. So, modulus basically means, modulus has a very simple definition. Modulus just means that you are counting the distance between the number 0 and your number. So if you are looking at -5, the distance of -5 from 0 is 5. Therefore, the modulus of -5 is 5. Similarly, the distance of 5 from 0 is 5. When we look at distance, distance has no negative quantity. The distance of 5 from 0 or the distance from 0 from 5, these are the same quantities. So modulus simply means that it's the distance from 0 of your number. And that is why the modulus is always a positive quantity. It's very easy to define also. If your number is positive, modulus is the same value. If your number is negative, modulus is the negative of that number. And the only number which is equal to its own negative is 0. And for that, the answer is also 0. So there is no problem. So this is how modulus can be explained. Right. So Umaji has asked one more question. Can you give some hint to solve the last question of week 3 assignment? So let me go to week 3 assignment and see what the last question is. Correct. So the question was I power I. So here one thing to remember is that I is an integer. It's not the complex number. Okay. So you have, for instance, you are taking 2 and then you take 2 square, which will be 4, and then take it square, because you are putting I power I, and then whatever number you get, you raise it to the ith power again. Okay, so you have 2 square square. So 2 square is 4, 4 square is 16. So when divided by 10, the remainder for 16 is 6. Okay, so 6 is a possible answer. The remainder of I power I, whole thing power I, when divided by 10, can be. So we need to see which of these possibilities can be the remainders when you divide by 10. So basically you are looking at the number I power I and then whole thing power I modulo 10. Modulo 10, what is this number? That's all that we are asking. So clearly if you are looking at I equal to 1, you will have 1 power 1 and then again that power 1 will give you 1. So the option 1 is correct. And then I think for 7, so if you take 7 power 7, then you get some quantity and then that raised to power 7, then that would give you 3. Or one should perhaps check what we get. Let me think about this. So if I take 3 power 3, that would mean 3 3s are 9, 3s are 7, 27. So you get 7 as the last digit. And when we take 7 cube, so when you are taking I equal to 3, 3 power 3, which is 27. Okay, and you are going to take modulus, ultimately you are going to take congruence modulo 10. So congruence modulo 10, either you can now raise 27 power 3, or you can go 27 modulo 10 already, which will give you 7, and then take 7 cube. So remember, 7 square is 49. 7 square is 49, and 49 into 7 is again 343. So that gives you 3. So 3 does come. Okay, so 3 is a possibility. I just told you that 6 is also a possibility. And then all other 2 and 4 cannot be the possibilities. That is something that you will have to check. So, meaning you can quickly write down all the 10 congruences and see what you can get from them. I think, among the odd ones, maybe only 1 and 3 are the possibilities. Among the even ones, perhaps 6 is the only possibility. 5 will come because 5 power 5 is 25, which is 5 power 5 will give you 5 modulo 10. That raised to 5 is again 5 modulo 10. So 5 will come and 0 will come. These are perhaps the only ones. Umaji has asked whether we can do this without taking particular number. Sometimes, because the numbers are so small, I think it's good to do it with the numbers. Good morning, Sahaji. This was also the question asked by Kasina Dhuni. I power I, whole thing power I, when divided by 10 can be. So I think I have already given the answer to that question now, which is that we have to take a number n, raise it to the nth power, and then raise it again to the nth power and see what is the uh, remainder that we get. Okay, so this is how one solves question number 10. All right, so we come back to Mayank's question. Mayank has asked how number theory can be used in cryptography. Okay, so what is cryptography? Cryptography is basically where you want to send messages by encrypting them. You would want to encrypt messages so that they can be decrypted by the receiver. So, one standard way to do this is to consider all alphabets A, B, C, D up to Z together with all the punctuation signs, etc., and the space. Space is also one uh, attribute. Space is also something which can be treated on par with a letter. So all these you can number them, and these will be some, say, 40 or 50 or something. So each of these has a number, and then you apply some mathematical operation on this, which are also the invertible operators. So for instance, you can multiply by 2 and add 27. So if you do this, whatever number you get, if you subtract 27 and then divide by 2, you are going to get your number back. So these are the things that you could do, or you could work with modulo some number. Suppose you are given these, suppose these are 40 total symbols together with the space, etc. And then we go modulo a prime which is bigger than 40. Suppose you go modulo 67. Now, when you go modulo 67, there are many possibilities, meaning it's a field, and therefore every non-zero number is invertible modulo 67. So you can multiply everything, say, by 23 or 24. Modulo 67, it is still invertible. And this is now more complicated because you have not just, in the usual number system, the earlier proposal I had was that you multiply by 2 and add 27. So that will still keep, if one number is bigger than the other number, then the resulting number would also have the same property. Whereas if you are working in the moduli cases, then this property will not be true, and therefore this makes it very complicated. This will make it difficult for people who don't have the algorithm to decrypt your message. So the point of encrypting using the modulus, meaning finite fields, and going modulo some prime, which is bigger than the number of symbols you have, is that it will allow you to encrypt your number in such a way that only that person who has the encrypting key and decrypting key will be able to encrypt and decrypt the message. This is a very basic way number theory is used in cryptography. There is also something called elliptic curve cryptography. So, with the help of computers, whatever big prime you take, it is often possible to decrypt the message. It will take some time, but with even with the if you have enough time at hand, then it is possible to decrypt the given message, and therefore the what people come up with is elliptic curves, which are some groups associated to finite fields, which are two-dimensional groups, and then you can work with those groups, which is slightly more complicated way to encrypt the messages. And then again, decrypting will be possible for only those who have the decrypting key. That is how the encryption and decryption works. Okay, so we'll come back to questions which are asked here. Venkata Narasimha Murthy, good morning. Solving system of simultaneous linear congruences by Chinese remainder theorem is very lengthy. That is true, but that is apparently the only one. Meaning, I think you have asked this in the other thing also, that is there any other simpler method? So, unfortunately, there is no simpler method. The point is, whenever we compare, Sagar is asking, what about quantum cryptography? I think that will have to come in another course, not in this course. So, we should look at, whenever we look at methods, we should look at where the method applies. So, for instance, if you look at Chinese remainder theorem, the Chinese remainder theorem applies for whatever, however big your system may be. If you have A1 congruent to N1 modulo K1, A2 congruent to N2 modulo K2, so on up to AR congruent to NR modulo KR, whatever your R may be. And if the K1, K2, KR are coprime or pairwise coprime also, then you can apply Chinese remainder theorem and solve it. So the beauty of Chinese remainder theorem is that it can apply to any system, or however big the system may be. This is why it is useful. And naturally, when you have one or two systems, then maybe we don't have to use Chinese remainder theorem, and therefore, whatever Chinese remainder theorem does, we can actually do it by hand. And so it may seem like, we are not doing very complicated mathematics. We are just doing some simple calculations and we are getting the answer. But we are actually doing the Chinese remainder theorem. We are doing the same thing, but because you have one or two moduluses or three moduluses and moduli, and therefore when you do the computations look very simple. But Chinese remainder theorem has the very good benefit, which is that it will work for any system that you have, however big the system is. All right, so that is one reason why we go for Chinese remainder theorem. So I hope that answers your question, Venkataji. So we now go to Bapi Saha's question, where is asked, can you explain the answer of problem 7 in assignment 3? So I think I have explained it just now, but I will again answer that. So you have Z27, A is in Z27, and we are looking at solution to 6x congruent to 3 in Z27. So 6x equal to 3. Then now there are 5 options: 5, 14, 23, 26, and the last option is A belonging to the set 5, 14, 23. Now, we should be able to read the mathematics as a sentence. Mathematics, mathematicians are some of the laziest people. So when they want to write mathematics, they are basically writing some sentences in some way. So let's look at the first option. The first option says A equal to 5. What does it mean? In English, it means A is equal to 5. When we learn in school, we learn to read it in this way: A is equal to 5. Now, when you say A is equal to 5, you are not allowing any other possibility. So, A is equal to 5 or A is equal to 14. These are all definite answers. If you are choosing A equal to 5, that means you are not allowing A for to have any other possibility. Whereas in the previous question, question 6, where we say that K can be any natural number, it means it can be natural number with congruent to 1 mod 5, 2 mod 5. There you are allowing it to have other possibility also. You are saying K can be a number with this, or it can also be a number with something else. We are not saying K is a natural number with congruent to 2 mod 5 or K is a natural number congruent to 3 mod 5. That's not what is being said. So in question 6, the options allow other possibilities. Whereas in question 7, the options are exclusive. And therefore, we will not have A, B, C as the correct options. Because if you have A equal to 5, then A equal to 14 cannot be correct. And therefore, the only option in question 7, which is correct option, would be the option E. I hope this answers the question of Sahaji. So, Sagar, welcome to quantum cryptography some other time. Mayank, I am glad that you are happy with the explanation on cryptography. So let me go and check the Google Sheet once again. Let me again come back to one answer which I have given. So there was a suggestion from a student saying that I should ask questions which have only one correct answer. This is a good suggestion because it allows me to explain my philosophy. You see, what happens all the time is that typically I think we are all quite busy and we don't have enough time to check all the answers. If there were the system where I would have asked only one correct option, and if you go on checking and suppose your second or third option is the correct one, you would not bother looking at the other options because you know there is only one correct answer. You will take that answer having found it and then you are done. Whereas I want my students to understand that there is this correct answer and the other answers are not correct because of this reason. I want my students to have a complete understanding. So, for this complete understanding, I am giving you questions which have multiple correct answers. So that even if you get one correct answer, you will not stop at that point, but you will keep looking at other options and you will keep checking whether those other options are correct or not. That will help you explain, that will help you understand why other options are not correct. There is this, I don't know if you have read this book, Anna Karenina. So there is one statement in Anna Karenina. It's a novel, very thick novel. So that novel has a line which says that all happy families are alike, but each unhappy family is unhappy in its own way. If we want to think of this mathematically, and suppose, for instance, when you do real analysis, we learn about sequences and we look at convergent sequences. Then all convergent sequences are alike. So convergent sequences are alike because they satisfy some certain pattern. Whereas the sequences which are not which are not convergent, which we know are called the divergent sequences. So the divergent sequences are divergent in their own way. Some sequences are divergent because they go to infinity. Some sequences are divergent because they keep oscillating. So each option in the given question is not correct because of its own reason. And I want my students to know and understand those reasons. This is why I give questions which have multiple correct answers so that people can check and find out what is the reason that a particular option is not correct. So Mayank has come up with another thing. Correct, very correct. These elliptic curves are the same ones that Andrew Wiles has used for Fermat's last theorem. Very good. Yes, Simon Singh's book has elliptic curves, but you know the elliptic curves can be defined over any field. And I think what Professor Andrew Wiles has used are the elliptic curves which are defined over number fields. And what I was thinking about are the elliptic curves which are defined over finite fields. So, in fact, I have given lectures on elliptic curves, and if you can find my YouTube channel, or you can just search on Google elliptic curves and Shripad Garge, then you will find some lectures on YouTube, and I think you should check those lecture videos, 1 hour each, maybe 2 or 3 lectures, given at different times. So those are all at the same level. Those all start with introducing elliptic curves and then doing something about elliptic curves. So those lectures could be of some interest to some of you. Correct. These elliptic curves are the same one which Professor Andrew Wiles has used. By the way, there is something called archive, ARXIV. So this archive is a portal where people keep their research papers and any other paper that they read, and they keep the papers in the archive. And recently, I came across an archive paper which talks about proof of Fermat's last theorem. It's a very interesting paper. So this paper starts how a student will think about understanding the proof of Fermat's last theorem. It's just a coincidence that I came across this 2 3 days back. So this paper starts assuming how a student would come across the proof of Fermat's last theorem. You know, Fermat's last theorem proof given by Andrew Wiles. There is this journal called Annals of Mathematics, the best journal in mathematics that is there. So there is a single issue of that journal, and it has 2 papers. Paper 1 is by Andrew Wiles on Fermat's last theorem. Paper 2 is by Andrew Wiles and his student Richard Taylor, where an intermediate step which is used in the proof of Fermat's last theorem is proved. So if you read the proof of Fermat's last theorem, hello, Mrunalji, hello. So if you read the proof of Fermat's last theorem, which is the paper of Andrew Wiles, and if you try to understand everything by going back to books, you would have learned all of the algebraic number theory that is developed until now. This is what experts say. All right, so let me repeat this statement. You take this paper on Fermat's last theorem by Andrew Wiles, read the paper, and make sure you understand every term, if necessarily by going back to books which describe those terms. Okay. And hello, Anurag ji. I will come back to your question. Okay. So you start with Fermat's last theorem by Andrew Wiles. Make sure you understand every term by going back to books if necessary. And ultimately, you will have to spend a lot of time. Maybe you will also have to consult with somebody who is an expert in algebraic number theory. But ultimately, you would have learned all algebraic number theory that is used. The Fermat's last theorem proof uses Galois representations. It uses modular forms. It uses elliptic curves. It uses Kumar theory. It uses the factorization of ideals into prime ideals. It uses everything that is used in the. It uses L functions. Everything that is developed in algebraic number theory is used in Fermat's last theorem. Some people can actually say that the algebraic number theory was developed so that Fermat's last theorem can be proved. In fact, it seemed that this is the pinnacle. This is the reason why everything was getting developed. Okay. So this is why the Fermat's last theorem is very useful. So Mayank and others, I will suggest that you go back and check the paper on archive, which is recently put, maybe in the last week. You can search for Fermat's last theorem archive paper. Archive spelling is ARXIV. Right. So Anurag has this comment. He found it interesting that I began the course with an algebraic approach instead of the usual well ordering and induction. How is this perspective useful? Correct. So there are many ways to start a subject. this reminds me of the movie called, of this series of movies of James Bond. I think if you have seen any of those movies, then there is a scientist in that movie. I think his name is Q, and he gives various gadgets to James Bond. One of them might be a watch, which will give, there will be a wire which will come out of the watch, and you can just press a button so the wire comes out, and it's a long wire. It can get stuck somewhere, and then James Bond can hang around that wire and go somewhere else. So there are many gadgets which are given to James Bond, prepared by Q. And when a given gadget is to be used depends on the ingenuity of James Bond. All those things are useful, but it's only up to James Bond to use them. Similarly, in mathematics, there is an approach of starting things with basic notions. All the concepts that you need, you define them beforehand. And once you define them beforehand and then slowly start developing your theory, you will use each of those concepts as they are. This is a very good approach for a book, for instance. If you are writing a book, you would like to have all the basic concepts somewhere so that you can refer to them when you need. So well ordering, induction, these are the things which are basic tools. And even though when we read well ordering, it seems like an artificial construct. It doesn't seem very useful, but it's immensely useful. The method of induction, the principle of induction is a very useful concept. But when we learn that, then it is not very clear how it is going to be used. This is the reason I have started my course in a slightly different way. Instead of going through usual definitions of the basic terms, then explaining those concepts, and then calling back about those concepts whenever I need. That is one approach, but I believe that for usual lecture course like this, it is not a very good approach, and therefore I have given the algebraic approach. Even when I teach here in IIT Bombay, I typically start my course with some, a question which is going to be a central question in the theory. And then I explain how the concepts were developed to answer that question, or even to study the question. Even if we may not be able to answer that question completely, we are able to get some understanding of the question. And that's the reason I have started the course also with the algebraic approach. I am very pleased that you have noticed this different approach. Venkataji is saying the solutions to system we get by CRT are the smallest. That may not be always the case. CRT has a method, meaning it gives the solutions using some algebraic operations, and sometimes they are not always the smallest solutions. So, no, your questions are not basic at all. They are very useful questions. Please keep asking them. So, indeed, the answers we get by CRT, but CRT is like one method. We should not get too much focused on CRT. Our main point is to answer our simultaneous congruences, and that's the reason that once we get the answer, we will keep CRT aside. We are going to learn many such methods like CRT. CRT is one simple method that we are going to use to get these simultaneous congruences. Later, we are going to see some systems where, which will, meaning there will be other questions which will give rise to the simultaneous congruences. And then we will use them, then we will solve them by the Chinese remainder theorem. So in the further part of the course, where we do quadratic residues and so on, we will see that some different question will have its solution in terms of the congruence, simultaneous congruences. And then CRT should come like a second nature to us. Whenever we see a simultaneous congruences system, we should think, okay, we apply CRT and get the solution. That's how we should think about it. So, meaning whether we get it a smallest solution, whether it's a bigger solution and so on, ultimately these things don't matter. That's how one should think about it. Right. So Sachin Rao is asking, good morning, Sachin ji. How does the solution to problem 5 in exercise 3 fit into the last method in step 3 to solve simultaneous equation by CRT. So let me see what is the fifth problem in simultaneous. Okay, so the fifth one says that if AN is congruent to 1, if the GCD of AN is 1, if the GCD of AB is 1, then there exists K in N such that A divides AB plus KN. Correct. So the question once again is, how does it fit into the method to solve simultaneous equations by CRT? This is here CRT is not required. You know, when we say that A divides the GCD of A and B plus Kn, the GCD of A and B plus Kn has to divide A, because it's the GCD of any two number has to divide each of the number, right? But we are also saying that A divides GCD. So when you have one number dividing the other and other number dividing the first, and we are talking here about the natural numbers, it means that both those numbers have to be equal, right? So when we say that A divides the GCD of A and B plus Kn, it means that A is equal to the GCD. Okay, this is the first small step that we have to understand. Correct? When we say that A divides the GCD of A and B plus Kn, then it means that A is equal to the GCD. But if A is equal to the GCD, that means A should divide B plus Kn, which means B plus Kn is 0 modulo A. B plus Kn is 0 modulo A, which means Kn is minus B modulo A. Okay. And now N is co-prime to A. Therefore, you can multiply by the inverse of N modulo A. And so you get an answer for K equal to minus B upon N modulo A. So that gives us the answer. Okay. So then there is a K in N such that this happens, that final property A divides the GCD of A and B plus Kn is same thing as saying that Kn is congruent to minus B modulo A. And now this has a solution because A and N are co-prime. Here we have not used that A and B are co-prime. That was an extra condition. I think I just put it to confuse some people, but luckily nobody has got confused. So this is how question 5 can be solved. Question 5 does not really require Chinese remainder theorem. I hope this answers the question of Sachin ji. Mayank, yes, please check those elliptic curves video and the Fermat's last theorem on archive. Oh, you have read Anna Karenina. Very good. Excellent. Ah, so Umaji is asking whether I can suggest some books. So, you know, in the course, or if you go to the webpage of our course, there are two books which are suggested there. I think the one book which I have used for this course is the book by Baker, which is a comprehensive introduction to number theory, which is an excellent book. You should go and read that book. The problem with that book is that it doesn't do some of the basic things which we are doing in the course. So for that, there is another book. Let me just go to the web page and tell you what the books are. I will quickly check. There are many books, meaning in basic number theory, there are many books. I just want to see which one among them I have put. Right. So there is a book by Niven and Zuckerman, which I have given there. So that's an excellent book. There is a book by Hardy and Wright, which is also a very good book. So these are very good books that you can look at and solve problem. Whenever we look at new books, you should not look at new books for the reason of looking at the theory again. Although some books do give theory in a different way, and therefore it is useful to look at new books for theory. But main interest should be to look at problems, because many new books come up with different problems. The exercises given there in the new books are different, and that is the reason you should look at some of these books. So Niven Zuckerman has an excellent list of problems. Hardy and Wright has a very give you a good practice of numbers. Right. So Kashina Dhuni ji, good morning. I have explained this, but I will explain it again. So this was, I think, the last problem in the recent assignment 3, problem 10, which is the remainder of I power I when divided by 10 can be. So the thing is that when you take I, so once again here, I is an integer. I is not the complex number. Okay, that is something we should understand first of all. So I is an integer and you are raising an integer to its own power. So for instance, if you look at 3, first of all, you are taking the cube of 3. Okay, so it is 3 power 3, which is 27. Modulo 10, 27 is 7. And then you raise 7 to the power 3. So 7 square is 49 and then 7 cube will be 343. So 3 power 3, which is 7, power 3, which is 3. That is how one looks at this solution. So if your I was 3, then 3 power 3 bracket power 3 will give you 3 as the answer. If you were looking at I equal to 4, 4 power 4. 4 square is 16, so 6. And 6 square is again 6. So once you have reached 6, there is no way out. Any power of 6 will just give you 6. Okay, so 4 to the power 4 is 6, modulo 10. And its fourth power is also 6, modulo 10. Right? So this is the way one could get I power I. If you are looking at 8 power something, 8 power 8. So 8 square is 64. 8 power 4 will be 4 square, which will be 6, which will be 16. That will give you 6. And now whatever power you raise to 6, you are going to get 6. So any even number, 2, 4, 6, 8, all these even numbers ultimately will give you 6 as the answer. If you are looking at 2 square, that is 4. 4 square, which is 16, so that answer is 6. 4 power 4 is already 6, and so because 4 square is 16, so 6, and therefore any power is 6. 6 powers will give you 6 anyway, and we have also seen that 8 powers will also give you 6. So for 2, 4, 6, 8, the answers are also 6. For 1, any power will always have the last digit to be 1. For 3, 7, and 9, the last digit always happens to be 3. This is something you can check. And no, I think for 9, one has to be careful. But for 3 and 7, the last digit is 3. For 5, the last digit is always 5. For 9, one has to be careful. Either it is 9 or 1, that one has to see. But among the given options that are there, we see that 2 and 4 cannot come, because for the even numbers, the only answer one gets, the remainder when divided by 10, is 6. And therefore 1, 3, and 6, these are the only correct options. Okay, so this is how one solves this thing. All right, so Sachin has modified his question. He meant in the step 3 in the lecture on solving simultaneous congruences instead of Sachin, I'm sorry. Can you ask this in the discussion session? I will answer it to you on that, because I will have to go back and check the video and see what the step 3 is. You know, these are videos which I have recorded a few years back, and now I myself don't go and see those videos every time. So I cannot just off the top of my head, I don't understand what the step 3 is. So if you ask this question in our discussion forum, Sachin ji, please ask it there. I will answer those questions there. Mrunal ji, thank you for your kind words. I have not given any other course than this, but there is some course which I may give sometime in the future. You know, giving a course is not an easy task. One has to record some 50 plus videos and then prepare question papers and so on. So it does take a lot of time, but yeah, I will try to give something. I don't know whether that will be related to physics or not. My physics is very bad. That is why I do mathematics. But yeah, I will try to see something. Thank you for the kind words again. All right, it's almost 11:20. I think we'll need to wrap up now. I will once again go through the questions which were asked in the Google Sheet. I think I have answered most of these. So if you have any further questions, you can ask them here, or we will have to then call it a day. Thank you, Kashina Duniji. It was a very good thing to have people commenting and asking various questions. No question is basic. Please do not think that your question is basic, because whatever I tell this from my own experience is that when I was in school and I would ask very basic questions, and then people will come and tell me that, this was the question they also had in mind. But not everyone, thinks that one should ask this question. So anybody who has a question in mind, please ask. I will try to answer all questions, even here and also on the discussion forum. So please ask your questions. Don't keep them back. No question is basic. No question is silly. I will once again go through the chat to see if I have missed any question. So Umaji's question, I think I have given the answer. Venkataji, his thing is also given. Mayank had asked about cryptography, which I did. Sagar question about quantum cryptography. Unfortunately, that is out of syllabus for this, so that we will do some other time. Right. Elliptic curves, yes, that is the same thing. Anurag's comment on the approach. Venkata's question on the Chinese remainder theorem. Then Sachin's question on class Chinese remainder theorem, which we will have to do by looking at the video. Umaji had asked whether some books can be suggested, and I think I did. Kasina Dhuni, Mrunalji asked about courses related to physics. So, okay, so I think I have answered almost all the questions. So, thank you, Mayank, for your kind words. I think we will have this session once again. We are supposed to have total in all 3 sessions. So, 4 more weeks, and we will have another session. Okay, this is a good suggestion. Please provide worked out examples in lecture sheets for every theory related in videos. So in my videos, I do solve some problems, but maybe they are not enough. So therefore, if you look at these books, this is something that we can try to do. But adding something, Venkataji, thank you for your kind words. If we add something to the videos now, that is going to be a bit difficult. What you perhaps mean to say is that I should add some extra document, right, Kasina Dhuneji? I think this is what you mean, that I should add some extra document where the solutions are worked out. But meaning, the point is that this is not as simple as it sounds, because whatever explanation I give, there will be some people who would not understand it, and there will be some people who will think that I am writing excessively too many things. This is the problem which comes when we try to give solutions and so on, meaning even our assignment sheets, I give some hints for all the problems, but sometimes for some people those hints are not enough, and sometimes some people tell me privately that I am giving too much explanation. So this is something that I should think about. You are right. I will think about this suggestion. I will keep that in mind. And if not now, certainly from the next course, I will try to implement it. Yeah. So I will think about this. Thank you for this suggestion. Okay. I think it is 11:25. We will ask the backend team to see if we can now stop, or are we? Okay, the backend team says that we have 5 minutes left, but we are done with all the discussion. So, I leave it to the backend team saying whenever it is correct for them, whenever it is convenient for them, we can stop this video. It was very good discussing with you all, and I look forward to the remaining two sessions. The schedule for that will be announced on the announcement list in due course. Bye.